Alright, so day 8 is about the law of cosines. Yesterday we talked about the law of sines, and we used the law of sines when we had either two angles and we were trying to find a missing side, or we had one angle and we're trying to find the other angle, but we knew two of the sides. So remember, the law of sines said a over sine of a is equal to b over sine of angle b. And also they had a third one with c in it, but we never needed all three. And we either knew both angles and we were trying to find one of the sides, or we knew both sides and we were trying to find just one of the angles, but we knew one of them as well. Now with the law of cosines, we use that when we are either trying to find one angle or given one angle. And there's actually three kind of different law of cosines that we use depending on what you are given. It looks way more complicated than it is. The one thing you need to know is that, we have the cosine of a, and then we have a squared, and they're on opposite sides of the equation. You have b squared and cosine of b. Those are on opposite sides of the equation, and the same thing for c. These are on opposite sides of the equation. And it's just so that you know where things go in the formula. It's probably so much easier to learn this as you see examples and try to talk about all three of these cases at once. So let's just go through the examples, and I'll go pretty slowly so that you can see how this works. Alright, example number 1. Let's draw triangle ABC. ABC, where A is 600 feet, so across from A is 600. B is 660 feet, so across from B is 660 feet. And angle C is 50 degrees. We're trying to find C, so we're trying to find the side across from C. So you see we have these that go together. Okay, we have an angle and we're trying to figure out the opposite side of that. We don't know another angle, so we can only make one of these loops. So that's kind of a way you can tell that this is going to be law of cosines. Now, law of cosines says that this side squared, the missing side here, so the side across from the angle we are given, so x squared is equal to a squared plus b squared. Well, it doesn't matter which one of these sides you make a squared or b squared. So 600 squared plus 660 squared. So you may think that this kind of looks like Pythagorean theorem, and it does. Pythagorean theorem is just like a special case of the law of cosines. Pythagorean theorem only works in right triangles. Law of cosine works in any triangles, just like the law of sine does. So the law of cosines also has this subtraction part up here, minus 2 times a times b times the cosine of c. So minus 2 times a, again it doesn't matter which one was a, so 600 times b, 660 times the cosine of c, so the cosine of 50 degrees. So that's a lot of math right there. So x squared equals, and what I'm going to do is I'm going to go a little bit slowly with the calculations. I'm going to do them one at a time. So 600 squared is 360,000 plus 660 squared is 435,600 And then I'm going to type all this in at once. So 2 times 600 times 660 times the cosine of 50 degrees. And that gets me 509,088. Okay, so then we will simplify this. X squared is equal to 286,512. So then we will square root both sides, and we get x equals 535.27 feet, because those are the units that were given to us. Okay, so like I said, that this is pretty confusing because there's so much going on. So it's a good idea just to take it bit by bit. Um, I will give you the formulas on your test to use, but you again need to know how to use them. Alright, let's look at example 2. The picture's already drawn for us, and we're trying to figure out BC, this side here. I'll use a different color. So BC. Okay, that's across from angle A. So these are going to go together. So then in my formula, side BC, or this X, will go on the opposite side of the angle measure. And then these are going to be my A and B value. So it's going to be X squared equals, again, it doesn't matter which one's A or B, so 1.42 squared plus 1.26 squared minus 2 times A times B times the cosine of 74 degrees. So just like last time, I'm going to do this little by little. You can type it all in at once. I just get a little uneasy when I do that because it's easier for me to spot an error if I do it one at a time. So I'm doing each part separately. It's very easy to hit a wrong button. I should be rounding these to 2 decimals, my bad. So 2.02 plus 1.59. Like I was saying, it's very easy to hit a wrong button. And if you type it all in at once, it may be hard to see that you've done that. So I'm just typing these in to my calculator. Okay. Now I didn't round 0.99 to 1 because it was 0.986. So 2 decimal places would be 0.99. So then I will do 2.02 plus 1.59 minus 0.99, and x squared is equal to 2.62, and then we square root both sides, and x is equal to 1.62 miles. So the hardest part with these problems is figuring out where things go. After that, you're just plugging it into the formula and using your calculator. Alright, let's flip the page. And it says, what if you were given the lengths of three sides? Could you use the law of cosines to find the measure of the angles? Yes, you could. What you could do is, if we go back and look at the law of cosines right here, is that if we know all three sides, we know what A, B, and C are, and we can plug those in and then try to find out what angle A is by using the inverse cosine. So what we'll do here is we'll solve for two of the angles, and realistically I don't like using the law of cosines. It's very long and drawn out. As soon as we get one of the angles, then we can use the law of sines instead, if you would like. And then once we know two angles, we can just subtract from 180 to find the third side. So we're just going to pick an angle to find first. So I'm going to pick this one. So these should go on opposite sides of the equation in law of cosine. So 5.9 squared is equal to 3.7 squared plus 5.4 squared minus 2 times 3.7 times 5.4 times cosine of c. We don't know what that is, or we can say cosine of x. It doesn't matter. So then we will simplify all this. So 5.9 squared is 34.81. 3.7 squared is 13.69. 5.4 squared is 29.16. Now this mess right here, we can multiply the numbers part. So 2 times 3.7 times 5.4. Okay, so it's going to be minus 39.96 times the cosine of x. So this is all one thing. I can't combine that. Okay, so what I'm going to do is I'm going to combine these two. So 34.81 equals, so in my calculator I'm going to figure out what that sum is. And I get 42.85 minus 39.96 times the cosine of x. I'm just double checking my math here that I typed everything in the calculator correctly. So then we want to get the cosine x by itself. So 34.81 minus 42.85. We get negative 8.4, 8.04. Okay, then we can divide both sides by negative 39.96. And we get 0.20 equals cosine of x. So then we will do the inverse cosine. We get 78.46 degrees. So the measure of angle C is 78.46 degrees. Okay, so that was a lot of work to get one of the angle measures. But now we can go back to our picture and say, all right, this is 78.46 degrees. And then we can use law of sines to find out one of the other angles. So let's work on angle B. So I'm going to use law of sines. These go together, and these go together. Now I'm going to show you something um, interesting you can do with the law of sines. The law of sines, I told you that, alright, the side length goes on top. Well, back when we talked about ratios, we said that we could flip both sides of the fraction. Flip this and flip this, and then that would still be um, a true statement. So what I'm going to do in this next problem is I'm going to put the angle measures on top, and I'm going to put the side lengths down here in the denominator, and we can do that. And I'm going to explain why I've chosen to do that. So I'm going to put the sine of b over 3.7 equals the sine of 78.46 over 5.9. And the reason I'm doing that is for speed. Instead of cross multiplying and dividing like we did yesterday, I can multiply both sides by 3.7. And what that will do is that will just leave me with the sine of b on the left side. Yesterday when we were trying to find an angle, we would cross multiply and then divide, and that will still work. If this is confusing you, then do the law of sines the way we did yesterday, where the side lengths go on top and the angle measures go on the bottom, and that will still work. This is just a type of shortcut. So I'm going to type all this into my calculator. So sine of 78.46, close parentheses, times 3.7 divided by 5.9, and I get 0.61. So then I need to do the inverse of 0.61, the inverse sine of 0.61, and that's 37.59 degrees. Now, you could have used law of cosines again. It's just this was a lot less work than using law of cosines. So that means angle B, I'm going to go back up to my picture now. Oops. Angle B is 37.59 degrees. Well, now I can just do 180 minus these two numbers, and that will give me the measure of angle A. So 180 minus 78.46 minus 37.59, and do this in your calculator, and you're going to get the measure of angle A is equal to 63.95 degrees. So yes, a lot of work to find out these angle measures. So this might be one that you'll have to replay once or twice to see what went on. Now, example 4, just like the other video, I want you to try this one and see what you get. And then after, pause the video, try it, see what you get, and then after you've got an answer, unpause it to see if we get the same thing. So go ahead, pause it, and try it. Alright, let's see how you did. A hiker starts out at point A and proceeds 6 kilometers to point B. He or she decides to retrace her steps, but mistakenly hikes along a path that is off from her original path. After walking 9 kilometers, she is 4.84 kilometers from where she wants to be. What is the angle between her original path and her final path? So we're trying to find this angle here, her original path, which was AB, and her final path, which was BC. So we're trying to find angle B here. Now, angle B is across from 4.84. So these are going to go together. So when we do the law of cosines, we're going to do 4.84 squared equals 9 squared plus 6 squared minus 2 times 9 times 6 times the cosine of b. We don't know what that angle is. Okay, so in the calculator, I'm going to do 4.84 squared. And I get 23.43. 9 squared is 81. 6 squared is 36 minus 2 times 9 times 6 is 108. So combine like terms. 81 plus 36 is 117. Subtract 117 from both sides. So 23.43 minus 117. That gives us negative 93.57. Okay, so then we'll divide both sides by negative 108. Whoops. I get 0.87. So 0.87 equals the cosine of b. So then we need to do the inverse cosine of 0.87. And when I type that into the calculator, I get 29.54 degrees. So the measure of angle B equals 29.54 degrees. Okay. So this is a confusing topic, I know, so it might take some extra practice to understand it and to really differentiate on when do you use the law of sines and law of cosines. So if you need to rewatch the video, try a couple of the examples again on your own to see if you get it. So make sure you ask me questions if you're confused. See you guys later.